Hey guys, welcome back. Okay, are you ready? This is your last week. Last week of new lessons. Well, technically you still have another week of review and taking your test, but this is it as far as new stuff. So you guys have made it. I'm so proud of you. I know that the last few weeks have been different and there's been a lot of adjustment that we had to make, but you guys have, I know I say this every week, but I mean it. I just think that you guys have pressed through so well and you have really stayed steady and consistent in getting your work done. And even in, so many changes, you guys have still just continued on and done so well. So I'm very proud of you and I'm very excited to be able to do your last 4 lessons this week. And then we will review next week and then you guys will take your test and that's it. So more info on the test to come. But yes, for now, this is what we're going to do and then we'll review next week. So in this lesson, we are talking about finding a whole when a fraction is known. So we've done a lot in terms of finding fractions. So when you're finding a fraction of a number, just think about, like if you're trying to find 2/3 of 60. Okay, well, if we're finding a fraction of a whole, this number is the whole, and we're just trying to find the part. And so whenever we do this, you guys know the process is that of tells us to multiply. We actually just did one like this in the warm-up. So 2/3 times 60, or 60 over 1, you could multiply. You could cross simplify first, okay? So then we multiply straight across, and we would get 40. Okay, so that process is very familiar to you guys. What we're going to look at today is a little bit different. Today, we're going to look at how to find the whole. So this number, when a fraction is known, okay? So they're going to give us like the part information and the fraction information, but we're going to be looking for the whole, okay? And we're going to do that using a little bit of a visual diagram, okay? So let's go ahead and dive right in and take a look at what this looks like. So if we have a situation where 2/5 of the runners in the race, side note, some of my friends and I, since this is about a race, just to, keep you guys interested and tell you about my life, which you may not really care, but I'm going to tell you anyway, just keep you interested, give you a little story. My friends and I during this quarantine a couple of my friends and I have continued running safely, socially distanced, as just to train for a race because we were originally training for a half marathon that we were going to complete at the end of this month. And so we just decided to keep training because we can still exercise and actually it's one of the only things we can still do. So why not? So we actually, since all the races have been canceled, we made our own half marathon route this weekend and we will actually be running our race on Saturday, half marathon. So say a prayer for me because that'll be by far the farthest I've ever run. It's 13.1 miles. So some people it's not a big deal, but I've never done it. So it's kind of a big deal. Okay, anyway, back to the question. 2/5 of the runners in the race are warming up. If there are 10 runners warming up, how many runners are in the race? Okay, so I went ahead and made a little diagram here just so that we could kind of have that ready to use here and I'm going to show you how we can break down the information using the diagram to help us figure out the whole, okay? Because we're looking for how many runners are in the race. That's referring to the whole amount of runners in the race. So we know that 2/5. So I went ahead and took this rectangle and divided it into 5 equal pieces, you can see, okay? So 2 of those fifths are warming up, and we know that that is 10 runners, okay? So if 2 of these equal pieces represents 10, then that means that each of them has to represent 5 runners, okay? You guys see how I did that? So if that is the case, and again, I knew to break this down into 5 equal pieces because it says 2/5. Remember, anytime we've got a fraction, the denominator tells us the whole. Okay? So that is how I knew to break it down into 5 equal pieces. So now we know that those 2/5 are 10, and we know that each of them therefore has to be 5. So if these are 5, remember these are all equal pieces. So if those 2 are 5, all the rest of these pieces are going to be 5. So then if the question asks how many runners are in the race, all we have to do is total them all up. So 5 5s gives us 25 runners. Okay? Awesome. Let's look at another one. Also, we could follow up that with the question, how many are not warming up? So if we know 10 are the 2/5 that are warming up, then there's another 3/5 chunk down here of 15 that are not warming up. Okay, so that's important to note too. Okay, now we're going to move on to a different one. So let's look at 3/8 of the townspeople voted. If 120 of the townspeople voted, how many people live in the town? Okay, so again, when it's, oh, I should have put a dash right there. Sorry. When it says, I think, oh no, actually it didn't have one in the book. Okay, never mind. So, when it says eighths, that tells us that we are splitting it into 8 equal pieces, which I did here. So there's 8 equal pieces in the diagram. And then we know that 120 of them voted, okay? And that, again, was the 3/8. So 3 of these were how many voted, and we know that the actual there was 120. So if we know that 3 of these boxes make up 120, then we could simply divide 120 by 3 to see how much each box represents. Well, 3 goes into 12 4 times. 4 times 3 is 12. Then we subtract and we get 0. Bring it down, we get 0 again. So that's 0 times. So each one of these boxes is going to be 40, represent 40 voters, okay? So if we are looking for how many people live in the town, we are looking for the total of all of these. Well, if those 3 boxes are 40, then we know all these other boxes have to be 40. So we are looking at 8 boxes of 40, and 8 times 40 would give us 320 townspeople. So that would be our whole, our total that we were looking for. Now, if we wanted to know how many did not vote, that would just be the remainder. So 320 minus 120 would just be 200. So 120 voted, 200 did not vote. Should always be in this category. Always vote. Do your patriotic duty. Okay. Let's see, we've got one more. So let's look at this last example. You guys are doing great. Okay, last one. 6 is 2/3 of what number? Okay, so they're really making it simple for us now, not giving us any more fluff. They're just saying 6, the actual, is 2/3. So remember that bottom number tells us how many boxes to split it into. So we've already got 3 boxes here. I went ahead and made the boxes for you on all of these, but remember, you would have to be making these boxes yourself, okay? So just make sure you remember that that bottom number, that denominator, is what tells me how many boxes to make, okay? And if it's 2/3 represents 6, then I know 2 of the 3 boxes make up 6. So that means each one of those has to be 3, because 3 plus 3 is 6. And if those are 3, then this other one also has to be 3. So then to find the whole, all I do is add them all together. And that would give me 9. All right, that's it. So just remember, you want to take the denominator. That tells you how many boxes to create. Then take your actual and split it evenly by how many boxes it represents. Then give that same amount to every single box. Add them all up, and you've got your whole. All right, great job, guys. Have a great week.